A sequence is a list of numbers. So if you take a look at this number, 1, 2, 3, 4, 5, and on, which we call the natural numbers, you will see that this is increasing by the same amount. It is, if you add 1, you get the next one. If you add 1, you get the next one. Then again, if you add 1, you get the next one. If you add 1, you get the next one. So the one that you want next would be 6. Odd integers, 2, 4, 6, 8, 10, 12. Again, if you keep adding by the same number, this time if you add 2, you get the next one. If you add 2, if you add 2, if you add 2, if you add 2, you get the next one. So the one after this one would be 14. 12 plus 2 is 14. When you have a list of numbers which is increasing or decreasing, it can also decrease. For example, if we have 10, 7, 4, 1, minus 2, you would see here it is decreasing by the same amount. 10 minus 3 is 7. 7 minus 3 is 4. 4 minus 3 is 1. 1 minus 3 is minus 2. Minus 2 minus 3 would be minus 5. So when you have a list of numbers that is increasing or decreasing by the same amount, we call this type of logical progression of the number an arithmetic progression. Arithmetic progression. So the progression of the logic by which it moves forward, it's arithmetic, and in short we write AP. So we can call this an arithmetic sequence, or if the numbers were added together, we would call it arithmetic series. So the difference between a sequence and a series is that in a sequence, it's just a list separated by commas. In case of a series, it's just the sum of the sequence. So an arithmetic series would look like 1 plus 2 plus 3 plus 4 plus 5 and on, and the sum of this, that would be the series. So regardless whether it's an arithmetic series or an arithmetic sequence, the logic by which it moves forward, the way it progresses, that's known as the arithmetic progression, or AP. If you take a look at it algebraically, you'll figure out what is happening. So the first term, or the first number, it's u sub 1. The second one is u sub 2. The third one is u sub 3. The fourth one is u sub 4. And if we keep on progressing like that, we can actually figure out what the general logic of a particular term can be. So we can do this by just writing it out like this. So if the first term, let us use for simplicity a term A. Let me call the first term to be A. So the next one, if we add by the same number, let me call that same number D plus D, then the second term would be A plus D. Then if we again add by the same number, so the third term would be A plus 2D. Again, if we add by the same number, because in an arithmetic progression it keeps increasing or decreasing by the same amount, it would be A plus 3D. And now you can see some sort of a logic emerging from here. So what we have over here is that if this is the first term, then u sub 2 is A plus D, u sub 3 is A plus 2D, u sub 4 is A plus 3D. That means un would be first term plus n minus 1 common difference. So u1 is A, u2 is A plus, if it is decreasing by 1, so 2 minus 1 is 1, so A plus D, u3 is A plus 2D, u4 is A plus 3D, u5 would be A plus 4D, and on. So from that you can get the idea how it would move on. So we can take a look at any arithmetic progression, be it a sequence or a series. You can figure out any particular term. You don't have to move in a linear one. You can find the position. For example, for this one, we want to find what number would be if it was the 10th term. So u10. So it would be the first term is 10 plus it would be Since this is 10, it would be n minus 1 on 9. Now we need the common difference. Now how do you find the common difference? The common difference is minus 3 because it is decreasing by the same amount. So the common difference is minus 3. This would be 10 minus 27, so it would be minus 17. So the position of the 10th term, that the value would be minus 17. Now another thing is sum of the term, meaning the value of the sequence. If you add up all the terms of a sequence, you get the series. So if you want to find the sum of the terms, how do you figure it out? For that, we can have an example. Suppose you're asked for add up the first 100 natural numbers or the first 100 positive integers. So we have to write 1 plus 2 plus 3 on and on up to 100. Now it might take a while to use the calculator and find out what is the total, but we can use a shortcut. If we just reverse this, and if we reverse it and write 100 plus 99 plus 98 and all the way here we write 1. So we have just written the same thing 1 to 100 but in the reverse fashion. The last term we wrote at the first and the second last at the second term. This is how we wrote it. So let's use some algebraic symbol to contain this. So let me use sum of 100 terms, S100, meaning the series. If you add up the 100 terms, the value of the series would be S100. So this one will also be S100 because the terms are the same, just reversed. So if you add the two series, you will see each number is the same. 1 plus 100 is 101. 99 plus 2 is 101. 98 plus 3 is 101. And this one is also 101. So if you add this one, just like x plus x is twice x, S100 plus S100 will be twice of S100. Now, since you're adding the same number over and over again, if you're adding x 5 times, it will be 5x. So if you're adding 101, there are altogether 100 numbers. So it would be 100 multiplied by 101. So this is 2 of S100. So therefore, you can write S100 equals to, send the 2 to the other side, it would be 100 by 2 into 101. So this would be, if you cancel it, 50 into 101, which turns out to be 5050. It means if you add up the first 100 natural numbers, it turns out to be 5050. Can we now use some algebra to figure out what is actually happening over here? So if you notice, if this is the first term A, then the second term is a plus d, then the third term is a plus 2d, and the nth term is a plus n minus 1d. Now if you reverse it, this would be a plus n minus 1d, this would be a, then this would be a plus d, then this would be a plus 2d, so it would be like that in the reverse order. Now if you add the terms, so this is 101, every term would be 101, so a plus n minus 1 into d would be twice a plus n minus 1 d. Every term would be this. Even this one would be twice a plus n minus 1 d. So if you add up 100 of those, in this case, since instead of 100 we are writing n, Sn, so that would be n times twice a plus n minus 1 d. That's what happens. So this is 2Sn. So let me write this out over here. Twice Sn is n times twice a plus n minus 1 into common difference. Therefore, sum of the first n terms is n by 2 twice a plus n minus 1 into common difference. So we can call this the sum of the first n terms. It is important to remember we are starting from the first term because it can be any term from the middle. So since it is starting from the first term, we have to call this the sum of the first n terms of an arithmetic series. So if you want to find S1, it would be 1 by 2 twice a plus d. This is going to be S1, this is going to be 0. So the 2 and 2 cancels and we get a. If it is S2, you get n by 2 or 2 by 2 twice a plus this time it would be 1d. Then if you want S3, that would be 3 by 2 twice a plus n minus 1 is going to be 2d, and on and on. So we have two very important formula or rule for this arithmetic progression, be it arithmetic sequence or arithmetic series. So if you want to find the nth term, you get first term plus n minus 1 common difference. If you want to find the sum of the first n terms, it would be n by 2 twice a plus n minus 1 into common difference. So this is how it works. One thing is important here, because the entire definition of the arithmetic progression is the common difference itself. So how can we find the common difference, and why do we call it the common difference when we know we are just adding the same numbers over and over again? If you notice here, 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1. Again, 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2, 10 minus 8 is 2. So if you want to find the common difference, what you have to do, you have to subtract the previous term from the next term. That means we can call this the common difference rule. The common difference rule is d equals to u2 minus u1, which is also equals to u3 minus u2, which is also equals to u4 minus u3. That's it. It's the difference of the previous term minus next term minus previous term. So that would give you the logic by which the arithmetic series progresses.